In this video, we're going to continue topic 5.6, and we're going to look at some background information on concavity and points of inflection. So the function has a point of inflection if f double prime changes sign. The function is concave up if f double prime equals a positive, and concave down if f double prime equals a negative. So very similar to increasing and decreasing. To actually find so these are the instructions on how to find the intervals of concavity. So we're to find the test numbers, which are basically critical numbers. Set up an interval from negative infinity, or you're going to find your test numbers or your critical numbers first. Then you're going to set up an interval from negative infinity to infinity in a table, stopping at each critical number or each test number. Pick the x values or in the intervals, plug those into f double prime. If f double prime is positive, it's concave up. If f double prime is negative, we write that it's concave down. If f double prime changes from positive to negative or negative to positive, then there's a point of inflection there. Justify using concave up with f double prime is greater than 0, and justify concave down using with f double prime is less than 0, or justify points of inflection with f double prime changes sign, and concavity is always open. It's always open, parentheses. So let's really quick go through this information. It's just another way to present kind of what we put in the left-hand column. So the first derivative is used to find, so first derivative is critical points, increasing, decreasing, max and mins. Second derivative is identifying intervals where we're concave up, concave down, and points of inflection. When we are given a continuous function, the first derivative, we find that when the first derivative equals 0 or does not exist. For a second derivative, same thing. It's a critical point in a first derivative. It has a possible point of inflection in a second derivative. If my first derivative is positive, it's increasing. My second derivative positive, we call it concave up. My first derivative is negative, it's decreasing. My second derivative is negative, it's concave down. If your sign changes from positive to negative, we've got a relative max. Negative to positive, it's a relative min. So whichever is first makes a difference. Whereas here, as long as we change sign, we have a point of inflection. Okay. To answer the question using f prime, we find any possible critical values where it's undefined, use an analysis chart or a sign chart to determine positive, negative, interpret the chart to answer the question along with proper reasoning or explanation. Second derivative, we find any possible points of inflection by finding where the second derivative is equal to 0 or undefined. Use a sign chart, interpret the question using proper explanation and reasoning. Okay, so notice that both involve the same processes and concepts. It's important to keep your work well organized and well labeled. It is also imperative to know which function f prime or f double prime we need for each problem.